Okay, folks, I've started the recording. This is Design 330. It's our live meet on Tuesday, April 20th at 10 o'clock, and we'll be going over electrical distribution, power panels, and I'll show you where you can find the demos for doing this, and we'll discuss briefly the discussion board. Before we do so, we'll look at what's due this week. This is our week 13 of the course. It's Facility MEP, Mechanical, Electrical, Plumbing, and we're doing the electrical sheets this week. So there is a playlist that you can check out in on. There is a submittal template that you can use. And here's what goes on each one. Okay, it's and a sample that you can follow. Now, my sample is not complete, and yours needs to be complete, and it needs to be your own work, although you can use mine as a guide. So this says what goes on each sheet. Your details, electricals 03.1, are detail 1 and 2 of your electrical. A few people have been putting, last week, you put some electrical details on your mechanical detail sheets. You need to be clear about what's a mechanical detail, an electrical detail, and a plumbing detail, and put them on the appropriate sheets. And if you have questions, you can check with me during my individual meet hours. And then the 3D visuals, it's a little bit harder to figure out what to put there. So I've made a sample for you. And again, for your part 2, you are going to make mechanical, electrical, and plumbing sheets. You should be making 2 of each every week so that by the time you're done, you have 6 details for each one. 6 mechanical, 6 electrical, and 6 plumbing. So access to important files, same place as last week. They're all in the same folder. You do have a new discussion board posting, which I'll do at the end. Hi, Alex. How are you?
Good morning.
Cool. So we're just cruising through what is up. I do want to add on the discussion board. There's lots of reasons why I'm doing this, and of course it's toward the end, and I think you know what you're doing pretty well. But let's take a look really quickly. It says record yourself, and it's an explanation. How did you decide? Um, if you can explain it, there's an old saying: if you can explain it, you know it. If you can't explain it, you don't know it. And I'm not really trying to push on you whether you know it or not, but you should know for yourself how well you know something. And a lot of times we know about something, but we don't know it. So this will help you understand how well you know something, and you can ask questions about it where you don't know. How did I do it? How did I decide? What did I think? And there isn't a right or wrong here. There's so many options available. But you need to be able to say and explain to somebody how you decided. Maybe you just say, well, I just put them wherever I felt like it, and it looked good. And that's a valid way of doing it. It's not very systematic. It doesn't help the electrician very much, but and they're not going to pay attention to you anyway. But being able to describe how you decided something is a key trait to a successful designer. So you want to be able to do that, and you need practice. So that's what we're going to do for the next 3 or 4 weeks. And recordings, it's one thing to write it down, it's another thing to say it. I would like you to record yourself and say it, whether you use just a record button on your computer or your phone, or you go into here and use the actual record system. One of those ways, I'd like you to do that. Okay, so let's take a look and see what's up for today. I'm going to discuss electrical distribution. How does power get to the light bulb, or to the computer, or to the refrigerator, or to the lathe or the mill? How does electricity get there? Then we'll talk a little bit about distribution panels, which is kind of part of this, okay? And then I'll talk about the individual um, things that are important in each one of these views that you've got. Now, I've given you demo tutorials, so I don't think I'm going to do a demo today. I'm going to talk about them. Tomorrow, if you have questions, and look, I know some of you can't make it to the live meet of the lab. You can certainly email me, and I should have said this much earlier on. It's amazing what we take for granted. If you want to see something demonstrated during the demo and you can't be there, just send me a message or an email and say, during lab, will you please demonstrate whatever it is that you'd like to see? And I will do that. And so from here on out, I'll try to make that more clear. It's amazing. Here we are almost a full year into doing these things remotely, and I'm still figuring out what people know and don't know and think they can do and think they can't do. So it's all a big learning experience, even for professors too. So if you need something demonstrated and you can't be there, please email me and I'll demonstrate it. And then it'll be recorded and I will record the demonstration. So there, I think that'll be helpful. But please look these over. They're pretty straightforward. I did the HVAC one. I will make a demo for one zone for the power receptacles, and we're not doing lighting. I think that's a little bit overload for you this semester, and so we're skipping the lighting. But it works exactly the same way. Works exactly the same way. Okay, so let's talk about power distribution. First off, that's a power distribution system. And it is how we do it. Something generates the power. And that could be coal burning and driving a generator. It could be natural gas. It could be hydraulics of water falling from high elevation on a dam down to the bottom and going through a turbine. It could be what they call a biomass topping cycle, where they just fire up a big furnace and burn a bunch of biomass to push a generator. It could be nuclear. However, it could be solar. It could be wind. Something turns basically a big electromagnet, and when the electromagnet is turned, it generates electricity. And so that's it. Now, that's, who knows what voltage it's at, who knows what cycles it's at, and all that kind of stuff. So when it comes off of the generator, it goes to something called a step-up transformer. And that makes it the same as every other generator in the state or on that grid. So this thing called the step-up generator sort of like conditions it and makes it all the same, so that when it goes into the wires, it's all at the same voltage, and you can work with it. Okay? And it's at a very, very high voltage, because the longer the wires are, the more power, more energy is lost. And so at a very, very high voltage, that loss is less. Okay, so it takes a high voltage. So look at this, 138,000 volts. What comes out of your wall sockets is 120 volts. This is 138 1,000 volts. So it's 1,000 times more voltage. Okay. But there are various ones that go through the transmission lines. These are all kV, by the way. These are transmission lines are all in the thousands of volts. Okay. Usually 138 or 230,000 volts going through those big wires. Okay. And then it gets to where it's going: Sacramento, Davis, Stockton, wherever it happens to be. And they have big substations. And that takes that super high voltage and knocks it down to something a little bit easier to work with. 26,000 volts. 69,000 volts. And that is what comes into, say, the college or an industrial plant. Or somebody, actually, that's more like these ones, primary customers. So sub-transmission customer is somebody big who's got a big campus to really send it around on. But then it'll come maybe to a primary customer, who would be American River College, a big manufacturing plant, the rail yards, and they're going to come in at 13,000 volts. Or maybe 4,000 volts. So when I worked at Wemco, we were 13,000 volts. And we had people come out and have to work with that and turn it off and turn it on so that we could install a new transformer or something. That's dangerous stuff, folks. Really, really dangerous stuff when it's that high voltage. Even 120 volts, we're very careful to keep people from sticking their fingers in a socket, because even 120 volts can do you in. So these are really high voltage, but it comes in, and there's a big box somewhere that it comes into, and then it spreads out through the facility. And somewhere in the facility, it gets knocked down to 120 volts or 240 volts, single phase or three phase, to run computers and light bulbs and refrigerators and mills and lathes and things like that. So it starts out at whatever, gets conditioned to a very, very high voltage that is regulated along the big transmission lines throughout the state. It gets to a location where you got a big transformer yard, step down substation that puts it into whatever is being distributed in your area, sent out to customers, and then the customers knock it down to the useful amount that your equipment uses. Okay? So that's how your distribution works. Now, once it gets to the secondary customer range, we're not worrying about this big stuff. We're worrying about some wires are brought to your building, your house, your apartment, your lab, your engineering facility, the building. At the building, you're always going to see some stuff that kind of looks like this. And sometimes it's bigger and sometimes it's smaller. But this is your power distribution panel. And this is a typical one for inside the building. And right here, your main power comes in. That's where your 240 or 120 volt AC comes in. And then you put it on, each wire goes out on individual circuits to the things in your building. This one goes to the microwave. This one goes to 10 plugs in your rooms. This one goes to the fume hood. This one down here goes to your lights. So you arrange your circuit breakers that you can just turn on and off. You want to be able to turn power on and off to individual things. They're arranged in a panel. Now, sometimes you arrange many panels depending on what's going on, and sometimes you're down to one small panel. So there's panels and sub-panels depending on how you've arranged things. But overall, there's one big cutoff. That's all the power coming in. And then it goes through individual circuits, things that you can turn on and off that deliver power, distribute power to devices. Now, to turn them on and off, you have this little thing called the circuit breaker. And there's a wire in and a wire out and a switch. Open the switch, no power goes. Close the switch and power goes. Okay, and this one's called a magnetic circuit breaker because it's got a very cool little magnetic coil inside of it that looks at how much electricity is flowing. And if it goes wonkers, and you don't have to know how it works, there's a little magnetic coil in there. If it goes wonkers, that coil goes boop, and it automatically turns it off. That way, it's an overload switch, so that if you have a piece of equipment that's going crazy and burning up, this is supposed to stop it. And it usually does. And these ones are called magnetic circuit breakers. Some of you might still be familiar with what are called the lug types that had fuses that basically just got hot and melted before your equipment would melt. But magnetic circuit breakers are cool. So you start with some big power station. You condition it with what's called a transformer to get it to very high voltage. You send the very high voltage along the power lines. And when it gets to where it's going, you step it down so that it's not quite so high. And then you send it out through your area. And when it gets to the location of the customer, you either step it down a little and send it out and around, or you send it to your primary customer and bring it down a little bit more. And then your customer has to distribute it throughout their facility, whether it be a set of homes, a set of buildings on a strip mall, a set of buildings on a campus, or one building like we've got with 3 or 4 different customers. So that's how it works. Does that sound good, Alex? Does that make some sense?
Yep, it makes sense. And we'll just see with the assignment what we have to calculate for the energy flow and all that. It's interesting about the power distributor panel that you just showed, because actually at my apartments we have each house has that same panel, right? But a
Yep.
smaller scale.
Yep.
Well, I kept smelling plastic burning, and then we looked in there and all the wires had burned because there was too much power coming in.
Oh no.
Yeah, so I was just thinking about, I wonder what caused it, understanding that there's so many parts that are controlling the amount of power coming through that it's kind of hard to know what overloaded the system. But it's
Yeah, well, depending on which set of wires it was, you can see, and what it means was that your circuit breaker either malfunctioned, which is a really bad news, or the circuit breaker was sized too large for what was on the circuit. So let's say your circuit breaker, let's say your circuit breaker was set for 10 amps, and you just had little wires coming out to a few small things, then that circuit breaker won't kick until 10 amps are used. And if your electrician used wire that was too small, it will burn up before your circuit breaker goes.
Oh my.
So, but you can ask your you know, you can ask somebody about that. That's kind of a common thing of what happens. But yeah, that's how it happens. That's how it goes.
Mm-hmm.
Okay, and that's why you have people called electricians. And hopefully you've got one that's trained and either is trained by a union or an apprenticeship program of some sort so they actually know what they're doing instead of just being installers. It's really good to have people that know what they're doing.
Yeah.
So there we go. Okay, so that's a power distribution system, and let's take a look. And that's also your distribution panels. Okay, and there's lots of types of panels, but that's one that you see, and they're all like this to some extent. And each one of these is a circuit breaker. And if you're on what's called single phase, each one of these turns on and off a series of devices. If you're on three phase, there's a wire from each device into one of these, and each of them turns off. So that's the difference between one phase and three phase. But we don't really need to know about that. So let's take a look at what we're going to do. I hate it when it does that. It just kicked me out. Let's take a look and see what your drawings are going to look like. So here I am in, is this the one I want? No, I think I want, here we go. This is our drawing set. So of pretty much what you're going to do. So let's take a look and see. The first thing you're going to do is notice that you have architectural views. We're not going to use architectural views. You have coordination views. We'll use those later on, but we're not going to use them right now. And then you have electrical views, and you should have HVAC, lighting, and power. And you tell what view it is from, I'll find it here, your discipline. These will be electrical views. And then you get to pick HVAC, lighting. There's even electrical views for plumbing because many plumbing fixtures now have electrical on it. Things like point of use hot water heaters. Even faucets now have sensors that turn things on and off, flushometers, things like that. So they even have electrical for plumbing. And they're set up so you can see certain stuff. So you're going to make sure that you have HVAC and power distribution. Those are the two that we're going to have. And I've got demos for you on how to do that. Okay. But that's how we separate it out. We want to know, okay, the HVAC is usually on its own power panel because it's a little bit different than all the rest and it's big. And if something goes wrong with, somebody's microwave, you don't want it to turn off accidentally all of your HVAC. And if your HVAC goes out, you don't want it to turn off all your lights. So often they will be in separate panels. And you'll see that I've got it set up for this customer. So each customer is going to have their own set of panels because the power company will put a meter on the front end of all of these panels. So there'll actually be a bigger panel with a meter on it so the power company can know how much to charge you. Okay? And the owner wants you to pay for the power that you use. And they don't want this person over here or this person over here to pay for it. Now, I actually did have a business in a building, and I could not understand why my power bill was so low after I expanded my business. I took over another room and I looked at the power panel and it was all marked and it said it was mine and I had air conditioning and I was running it all the time and my power bill just seemed really low. And after about 3 or 4 months, I asked my neighboring businesses, and one of the guys said, "Yeah, my power bill just shot up 3 or 4 months ago. I can't understand why." Well, they had the power panels mismarked, and he was paying for my power. And so I needed to pay him a whole bunch of money because it, you know, my power was running through his meter and it was a mess. It took the guy a lot, the business owner, the building owner, to correct it. So it's very, very critical that you get the power panels for a business assigned to a spot. And that is what's called part of the build out allowance when you rent or lease a facility. The owner needs to pay to get that right. And usually when you sign a 3-year lease or a 5-year lease or something like that, the owner is going to say, all right, you get $5,000 worth of build out. And that's one of the first things that you pay for is getting the electrical system, the power, um, wired and identified properly to you. Okay, so there'll be a big power panel. There'll be one power panel that is for the HVAC. Now let me show you what that's going to look like. 3D views. That it? Nope. Nope. I'll get it down here on my visuals. Oh no, where did it go? I must be in my wrong one. Wonder where it went. Let's see if I can find it in my drafting views. There it is. I need to go put that back on there. And so somewhere on the building, you're going to see a bunch of these power panels. And there'll be one more here that ties them all together. Okay. And there's a power panel. Which one is that? If I go and look, it'll tell me which one that is. That's my equipment power panel. And this one is my lighting power panel. And this one is my receptacle power panel. And this one's my HVAC power panel. So you'll have multiple power panels on the building that will all go to our use. Now, some places don't do that. Some just have a whole bunch of circuits on one power panel that you just assign to whatever you want to use. But I'm doing it very purposefully in these different manners so that you can see the different uses. These could all be in one big power panel or two. Okay, does that make sense? Hopefully. So that's kind of where the power panels are and how they work and what they do. So let's take a look again at how to set up your view. So this is, as an example, a power view. And there's a few things that I want to show you. One is I have added the space plant, the zones, to make it easier to view. This is not always done, and you don't need it. But I put it in there just in case I felt like it. Okay, I think it does make it easier to see. What goes on a floor plan for your HVAC are your AHUs and their description, and what power panel they're on, and what circuit they are on. So there's a wire going into circuit breaker 1, 3, and 5. And you don't have to worry about that. It just does it. And if you look over here at this thing called the system viewer, view, user interface, system, I've set it to look at my electrical, and I've set it up so that you see load and voltage, which is really cool. You can put all sorts of different stuff on here, but load and voltage are really cool. And I don't know why I don't have a voltage assigned, but I should. But I do have them assigned to what's going into it. So as an example, on my HVAC, I can see that I've got one unit going into 135. Look at that. When I clicked on it, it showed up over here. Isn't that neato? I just think that's the coolest thing. It really helps me figure things out. Super, super helps me figure things out. This one is my zone 1. And it's showing where it goes. And it's telling me what circuit breakers I'm wired into. That's super useful for the electrician. Super useful. They can pull their wires and number their wires and know where to put them into as they go. They can also make sure that the wires are big enough and all that other kind of stuff. So this is really useful. And look, it even tells me that I've got a cool air handler in there and how big the air handler is. Okay, and if I want to look at which air, look, it even shows me which one it is when I click on it. This is the most useful tool. And this does this also. I think I showed this to you in HVAC. Super useful tool. So I've set it for electrical and systems. Okay. Are there other things to look at? I can look at zones, analytical systems, but this is how I like to look at it. So this is very, very useful to me, and I kind of like it. So that's what goes on here. Now, as I look at these, you have to find the tags. So that's a panel tag. This one you've already found, a mechanical equipment tag. And this one's called a wire tag. And I've got demos on how to find those. But remember, when you go into these, they don't come out right to begin with. So you're going to have to double click. I don't think I'll save my project. And then click on what's there and edit that label to follow what I've got. And I've shown these on the demos so that you can go back and know what to put on here to make yours look like mine. Okay, but you can see how useful this is. It tells me that that one right there is going to go to which power panel? ESC HVAC, Environmental Systems Consultants. Okay. When I was running my judo club, it was DJK, Davis Judo Kai, and then there was one for HVAC. And then where I ran my club, they had one for HVAC, and then they had one that was lighting and receptacles. So I had 2 power panels. Of course, I really had an extra one because it was done so poorly that the poor other guy was paying for my power. That was really hard to figure out too, by the way. So there we go. So you want to be able to know that this one goes to here, and you do that by putting a wire on it. Let me demonstrate really quickly how to do that. You go to Systems, and you just add a wire, and I need to find what there. That one, it's got the little node symbol. It's really hard to see on here, but it's a little node symbol and it hooked up. 1, 2, 3, and then I'm going to tag it. Annotate, tag by category, and you'll have to figure out how to get that tag by category. But look, then when you click on the tag by category, you have to undo the leader line and then move this into place. There we go. Get that back. So those are a few little tricks of what you should see. If you can get this done in the next day or two, that'll be great. Your receptacles and your junction boxes are pretty, they're fairly simple, fairly straightforward to do. So for your views, your visualizations, I just made a camera view to look at these. I think that's cool looking. There's that camera view. And you can leave stuff on. There's a lot of hiding stuff in view. A lot of hiding stuff in view to get things to look a little bit better. Right? You can, although you can leave that stuff, but I don't think it looks good. Right? So you can go through and just go through your work of hiding things till this looks good. There's a lot of just getting down and making stuff look a certain way. But that's how I got that view. The other view that I think looks pretty good is, let's see, where is it? Where did I put the, oh, they were drafting views, I think. You can put, let me go find that. That's in coordination. Not that one. There it is, HVAC circuit visual. So what I did to get this one on a drafting view is I just turned on, and I've showed this in the thing. I've come back to here and I said, well, just show me that, those sets of circuits. So I just highlighted and I held the control key down. I just highlighted all 3 of those. I took a snip and I put it onto a drafting view because it really does show that. And when you do that for each one of your receptacle zones, it really looks cool. So you can have each one of these circuits or a few of these circuits in each visualization to show. And that makes a really nice visual without gooping up a drawing. Okay, so that's how you make those. Those are your visuals. What else is on here? Let's look at my sample that I gave you. This week, you're going to be responsible to make a sheet with your power panels and your panel schedule. I have demo videos for each of those. Your electrical power distribution, and let me zoom in here just so that you can see. You'll see that there's 2 things. There's receptacles and junction boxes. Receptacles are already wired up and there's a plug that you plug into it, that you put your device in. It's the wall receptacles that you've got. And then there's things called junction boxes. It's basically just a box where the wires are there and they've got caps on the ends of the wires. And if I have a lathe or a mill or something, an electrician does the work to wire my piece of equipment into the junction box. So that's called a junction box with a load. And so I can set those up. Now you can see these little numbers here. Okay, those little numbers tell me what circuit it's on. So these receptacles are all on circuit 1, circuit 2, and then I've laid these in here, but I haven't done all the rest of the work. And these junction boxes are laid in here as an example. I haven't done that work. And then I don't know why, for some reason. Oh yeah, I've got two power panels back here. I've got one for my lighting, which are my receptacles, and then my junction boxes are three phase. So they go into a slightly different one. So um, I use two different ones, one for equipment and one for lighting, just to separate them out. They did not need to be separated, but I did. I made one for receptacles and one for equipment. Many places think that that's too much work and it's expensive. But you'll find with Cal Green, where they want you to now monitor subsystems for how much energy you're using, putting in a panel is a great idea. Okay, so let me reset the zoom. So you're going to have one for HVAC and the schedule, one for receptacles and the schedule, and then one for your calculations. These are your calculations from 2 weeks ago. And then this one's cool. This is just a screenshot of your system that shows your loads and your voltages, just to give an idea of how things are laid out. Your last one are your electrical details. So you'll do 2 more electrical details this week. That will be 2, 4, 6. You should have 3 pages of electrical details to add in. And then your visualizations. So it's really good to see your power panels and where they are and how they're aligned. And then it's really good to see many of your circuits and how they're set up. So I think that you should do 3 or 4 pages of these visuals. We'll see how much time you've actually got. But there's a sample. Most of you have never seen these types of drawings. And so this is a very common way of showing them. And I'll go more into these on Thursday. Particularly, Thursday's lecture will deal with this sheet. I don't really need to think I'd need to do this sheet, your electrical calcs or your details or your visuals. I think you pretty much get those. The next big chunk is going to be on the power distribution sheets. Okay, so let's see. I think that is most of what I needed to do. Add these are all demos that there are videos for. And I talked about the discussion board briefly, so I'll go back to that one again. Explaining your design choices. Important. So really do make an effort to do that. And then listen to it. It's actually okay to make some brief notes. If you just read something that you've written, that's okay, but it's really not as good as being able to just speak it. But you should maybe write down the points you want to make, right? I thought that every 12 feet was the most important. I wanted to get close. It wasn't exact. I wanted to check out to make sure that things could be grouped well together. I wanted to make sure that there was a GFC, ground fault circuit interrupt. Sometimes they're called GFCI, ground fault circuit interrupt, on each circuit, and for sure one in each bathroom. And as I was assigning them, I had a hard time remembering. So personally, I used this type of a thing so that I could see. Let me go into my electrical power floor plan. So like if that I used my system viewer to make sure that I was going all to one. Isn't that cool how that looks? It shows you what's on each circuit. It's just so cool. And so that's how I was able to do it. That's the tool that I use. Some people just start getting their drawing done as they go. I tend to assign my circuits and then put them on there. So that's part of of doing this, and it shouldn't take more than a minute or two, and it'll really help you know yourself whether you understand this and where you need to ask questions to get clarifications. Um, as most of you know, being a student is hard work. And one of the hardest parts is to figure out what you don't know yet. You're so involved with, I got to do this, I got to do this, I got to do this, that knowing what you've learned is sort of like, oh, what? That's the part that we sometimes skip. So I'm trying to help you take some time to know what you've learned or what you've not learned. Okay, so there we go. That's your work for now. This week, your discussion board posting, and for today and tomorrow, the work on your HVAC power system. Any questions?
Not yet.
Okay,
But I'll
then
probably book something later this week.
okay, that sounds great. And as a reminder that as you run into a problem, if you need to see me do it on one of the labs and you're not able to be there, just shoot me an email that says Design 330 lab, Wednesday the 21st, Friday the 23rd. Please um, um, demo something, and I'll do that.
Okay, perfect.
Cool.
Thanks.
Okay, there we go. We'll see ya.